All right, guys, I've got one more example for you. This was also a homework problem we had. This time we've got two sides of a triangle with side lengths, 12 meters and 15 meters. The angle between them is increasing at a rate of pi over 90 radians per minute. Remember, in calculus, we don't use degrees, it's only radians. How fast is the length of the third side increasing when the angle between the sides of fixed length, they just told me something important there, is pi over 3 radians. Fixed length means that these two sides are constant. That's super helpful. It's going to make this a lot easier. I'm going to have less variables. The fewer variables you have, the easier these problems are. But as always, we will start every word problem by drawing a picture of what's happening. I've got a triangle. I don't know much about the triangle. I'm reasonably sure it's not a right triangle, so just don't draw a right triangle. We have two sides with 12 meters and 15 meters. Those are fixed length, so let's go ahead and note that those are constant. You can call them A and B or X and Y, give them some names, but they're constant, so let's just call them their value. The angle between them, I like to use theta for an angle, is increasing pi over 90 radians per minute. And they didn't tell you much about this, but there's another value that's changing. The third side is changing. Let's call the third side, if this is A and B, this would be C. But you could call it whatever you want. Names are completely free form. You choose them however you want to. That side is increasing. I'd like to know how fast. Now, just looking at my units here, these two sides are measured in meters. Probably measured in meters as well. Time seems to be changing in minutes. So my time's also going to be changing in minutes here. This is always subject to change, but usually you can look at the rest of the units in the problem and set it up so that it makes sense. All right, we're getting ahead of ourselves, so let's make a list. We need variables and rates. Every variable has a rate. I see two variables in this problem, theta and c. So I'm going to have d theta dt, or theta prime, and dc dt, or c prime. I don't know c. I don't know dc. I'm looking for dc, though. Let's go ahead and box that. Meters per minute. It's going to be my units on it. D theta, they told me. Pi over 90 radians per minute. You don't have to write radians, but it's changing per minute. And then theta, at one point in time, I didn't write it in my picture. The moment in time I care about is pi over 3. Again, that is radians. You don't have to specify that it's radians. It is implied to be radians without writing it. I don't know c. Which brings me to my next question. I need to write an equation that has the c in it. Preferably that also has the pi over 3 in it, or the theta, I should say. I need an equation that connects c and theta. Let's look at our picture here. Theta and c are opposites. You guys know a few equations that involve opposite angle and side pairs. In particular, when you know the other two sides, and if I know this angle, if I know a side, an angle, and a side, and I'm looking for the opposite side, that's a law of cosines problem. Step 3, writing the equation, is by far the hardest part for most people. Some people are really good at it. For most people, including myself, this is where you got to stop and think. This equation can be anything. Any formula you have ever learned. Sometimes there's more than one possible way to go about it. Most of the time there's a clear answer, though. In this case, you got to remember from pre-cal, the law of cosines connects the theta and the c. Now, the good news is on the AP exam, they don't ask anything too crazy. Now, you do have to know law of cosines, but it's not super likely you would get law of cosines in a question like this. On the really hard problems, they will sometimes just tell you what the equation needs to be. However, I need us to know this, so I am going to occasionally give you a problem where you've got to recall stuff like the law of cosines. So we're going to practice. The law of cosines, you may remember, starts out a lot like the Pythagorean theorem. In fact, it is the Pythagorean theorem up till you get to this point. And then it diverges a little bit. C squared equals A squared plus B squared minus 2AB cosine of C. I need to make this equation work for me. So let's make some modifications. Once you write this equation, you get to go ahead and plug in your constants. It makes things easier if you can put the constants in. So C squared equals 12 squared plus 15 squared. Those are constants. And I don't really like that I'm using C here. This lowercase c is a side. This capital C, let's replace that with theta, because that is what I've called my angle. Now let's clean it up a little bit. 12 squared plus 15 squared is 369. 2 times 12 times 15 is 360. And at this point, I think we could actually go ahead and find this c. Let's do that. C squared equals 369 minus 360 cosine. Now c is going to change, but the moment I'm going to care about is when theta is pi over 3. I want the matching side. So let's put the pi over 3 in here. You could actually do this by hand, but we've got a calculator, so we'll go ahead and use it. 369 minus 360 cosine of, make sure you are in radian mode always in calculus, pi over 3. I get 189. Now, keep in mind, that's not c. That's c squared. So c is going to be the square root of 189. The square root of 189 is 13.74772708. I don't want to deal with that. Let's leave it as the square root of 189. I can always get something different if I need it. Square root of 189 works fine for me. So now, we've got our equation. We've solved for c. We've got all our variables, all our rates. We're ready for the derivative. This is the part that makes it calculus. The rest of this is just algebra and trig. So this is my equation. Let's take the derivative. Derivative of c squared is 2c dc dt. We're taking the derivative with respect to time. So the c squared gives me 2c. I do a chain rule, or the implicit differentiation, times the derivative of c, which is dc dt. If I plugged in my constants already, this 369 is going to go away. Not this 360, though. That's a coefficient. I'm going to say negative 360 times the derivative of the cosine theta. Well, the derivative of cosine theta will be negative sine theta times the derivative of the theta, which is d theta dt. Let's clean it up. 2c dc dt equals, the negatives will cancel. And I'm solving for, what was it, dc dt? Let's go ahead and get that dc dt by itself. Let's divide the 2c. And that brings us to our last step. We're actually going to solve. We know theta, we know c, we know d theta dt. I want the dc dt, which I've gotten by itself. dc dt will equal 360 sine of pi over 3 times pi over 90. Again, that pi over 3 is inside the sine. Divided by 2 times the square root of 189. Toss that in your calculator. On a TI-84, you can actually even type in the fraction. If you're doing this on any other calculator that can't do the fractions like that for you, just take it slow. Don't do it all at once.
ESS teachers, please release your students.
Please disregard the announcement that was just made over the intercom. It is ESS Day. Sorry about that. I'm not going to edit this out, so sorry. So we have 360 sine of pi over 3 times pi over 90 over 2 times the square root of 189. Looks the same. Hit enter. I get a really, honestly, almost concerning number. If I were in algebra and I got an answer that looked like that, I would definitely think I messed up. because I'm coming from a world where I'm used to my teacher giving me problems that work out to nice, neat, whole numbers. You're not sheltered anymore in calculus. Sometimes we get weird numbers. This is one of them. So don't be surprised if you get problems that give you answers like this. It's entirely okay. And this is not a very big number, but pi over 90, it's not a very big change in the angle. So don't be concerned. This is a small number, so is this. So we've got 0.3958, or we could say 0.396 is our answer. Again, it is dc dt. C is measured in meters. Time is measured in minutes. So I'm going to have when the angle is pi over 3, the opposite side is increasing 0.396 meters per minute. I want to reiterate again, these problems take practice. Don't be concerned too much about where I pulled that equation from. This is where all the nuance happens. The equation can be anything. That will come with practice. We need to be very, very competent at finding derivatives and plugging in values and solving. And this is the only way to get better at these is just to do a variety of problems. So find some more, find some different kinds of problems, draw some pictures, practice figuring out what the variables and the rates are, and practice connecting them with an equation. There's only so many different equations that you can be asked, but you won't know that unless you practice a bunch. So in this case, we have our answer in context. The answer says when. My answer is important when the angle's pi over 3, because that's all they gave me to go on. What is changing and how much? Gotta have those units. All right, guys, good luck.